Okay, all. So in this video, I'm going to conclude the application chapter basically. So till now, what we have seen that if there is one DB and everything is working properly, and there is a client, okay, and he reads and writes from this DB, cool. But what if something happens like IP on this IP on this server and it gets short circuited, then they are screwed. They can't do anything. So what did we do that we copied the data in multiple DBs. Okay, we copied the data to multiple DBs, and if IP on top of this gets destroyed, but they have replicas in this 2 DB and they can read and write on this DB. Cool. So the first benefit is basically we have durability. Okay, and again the second thing is like if there is a DB and if a person is writing on top of it and it's replicated like in multiple places, then other can just directly read from the like DB. Okay, read from the DB. So the throughput is also like better. And the third thing is like, for example, if it's in America and it's in India, it's in, I don't know, Europe and it's in Australia or somewhere, so everyone gets their own database, and like the speed is fast. So again, like this throughput is better. Okay, so this is why we need replication. Then second thing what we have seen is single leader replication. What is single leader replication? Where there is only one leader and there is multiple followers. Okay, there are multiple followers. Now the replication can happen synchronously or asynchronously. And synchronously, what happens basically is the until and unless the data is like replicated to each of the followers and the leaders, we don't say the client that it's completely done. So in that case, uh, the consistency is like 100%, but it's extremely slow, so it's nonsense basically. So what actually happens practically is that the replication happens asynchronously basically. So in asynchronous application, we write it to the leader, okay, and eventually it gets written to the followers. Okay, so it's basically eventual consistence eventual consistence. And second problem is like if the leader goes down, then we are screwed. So single point of failure. Okay, but the good thing is there is no conflicts. Okay, then to omit these two problems, like what we did, we obviously the eventual consistence cannot be omitted, but for like single point of failure, what we did, we went to multiple leader. Okay, so in multi-leader replication, what happens basically, there are multiple leaders and they have their own set of followers. Okay, and the client can basically write to any one of the leaders. Okay, so here we have learned about different topologies like star topology, ring topology, but what we end up using was a hybrid method in which we use both star and ring topology. Okay, but with this great, so what are the pros and cons basically? So the like throughput is extremely low because there are multiple leaders and anyone can write anywhere, right? So yeah, cool. The throughput is less, but what problem is it comes with is basically the write conflicts. Now we have understood like how can we minimize write conflicts, or how can we deal with write conflicts. So we have seen version vector. Okay, we have seen CRDTs, we have seen operational uh, transform, whatever the spelling is. Okay, we have seen how basically Google Doc works, how basically Raft works. Okay, how basically, yeah, those things works. Okay, cool. And why shouldn't we like depend on timestamp for all this, like for resolving right conflicts? Okay, then next we learned about leaderless replication. So basically in leaderless replication, there is no leader. Okay, so the guy can write basically in any DB and can read from any DB, where we have learned like write plus read should be greater than n, where n is the number of nodes. We have learned about Merkle tree. We have learned about anti-entropy. Okay, and the pros and cons. So basically the as we can see that we can write to any of the nodes and we can read from any of the nodes. The throughput is high, and we use Quorum for read and writes. So we can say like it's eventually consistent and the risk of conflicts is less. But obviously there is risk of conflicts. You can see the video of leaderless replication when there can be risk of conflicts. And uh, yeah, and like we are writing to multiple dbs, and what if like this fails or some problem like that, in that kind of condition, in failure condition, the throughput can be high. Okay, so this was basically the conclusion of the whole replication chapter. Okay, go to the previous videos and see like in details like how everything works. It is nice. And if you like the video, just if you like the series till now, just like, subscribe. Thank you.